Good morning, students. In the last class, we have discussed about the xenon compounds. Okay, and I have given some homework, some of the molecules as homework for you. But only few students, one or two, have turned up, and this is the structure of xenon oxy tetrafluoride we are discussing now. Xenon oxy tetrafluoride. How it is prepared? By reaction of xenon hexafluoride with silicon dioxide or hydrolysis of xenon hexafluoride. It gives xenon oxy tetrafluoride. Another method is xenon untreatment with fluorine and oxygen gas also gives xenon oxy tetrafluoride. So this is the preparation method, and coming to properties and its structure and hybridization. So xenon has 8 valency electrons. Valency electrons are 8 because it's a 8th group element. So you have to form 4 sigma bonds with the fluorine, 4 fluorine atoms, and one double bond with the oxygen atom, and one will be lone pair present here on xenon. So now what is the number of lone pair and bond pairs in xenon? There are 5 bond pairs and 1 lone pair in xenon. Total number of bonds are now 6. So 6 means sp3d2 hybridization, but due to the presence of one lone pair, this undergoes the general shape should be octahedral. It should be octahedral, but the lone pair, due to the presence of the lone pair, its shape is converted into distorted octahedral. Okay, its shape is converted into distorted octahedral. Okay, then next one is xenon dioxydifluoride, XeO2F2. So here in the examination you have to write like this. First you have to write the ground state configuration of xenon, then you have to write the excited state configuration. Now you have to know the xenon dioxydifluoride structure. So 1 2 will be the bonds with the 2 fluorine atoms, and 2 electrons will be formed with the bonding with oxygen, 2 other electrons will be forming with the another oxygen, and here also you will be left with one lone pair of electron. ఓకే, జీనాన్లో ఉన్న 8 ఎలక్ట్రాన్స్లో 4 ఎలక్ట్రాన్స్ ఆక్సిజన్తో బాండ్ అవ్వడానికి అండ్ 2 ఎలక్ట్రాన్స్ 2 ఫ్లోరిన్లతో బాండ్ అవ్వడానికి యూజ్ అవ్వడం వల్ల యూ విల్ హ్యావ్ వన్ lone pair of electrons on xenon. Okay, now how many bond pairs? 4 bond pairs and 1 lone pair. Okay, so now what will be the shape of the molecule of xenon dioxydifluoride? It is like this. The lone pair will be like this in the trigonal planar, and the 2 fluorines will be like this above and below, and due to the presence of this lone pair, here it assumes a shape of seesaw shape. Seesaw like this. Okay, the lone pair will be here. Seesaw, it's a plaything found in the parks for children. So this is shape is seesaw shape. Okay, now you consider the molecule xenon trioxide. Xenon trioxide, what is the hybridization and shape in xenon trioxide? You will have 3 oxygen bonded with the xenon with the double bonds. Okay, how many lone pair electrons left? Only one. So 3 bond pairs, 1 lone pair. So what is the shape? Shape is pyramidal, and hybridization is sp3 here. Okay, so this is about the hybridization shape and structure of xenon compounds. So this notes is shared in your group, so all of you have to follow the notes, make a note of all the xenon compounds. Only important question from this chapter will be about xenon compounds. What are xenon compounds? The combination of xenon with either fluorine or oxygen, sometimes oxygen and fluorine, like xenon dioxydifluoride, xenon oxy difluoride, xenon oxy tetrafluoride, or xenon fluorides. You have 3 types: xenon difluoride, tetrafluoride, and hexafluoride. And oxides you have trioxide and tetroxide. And xenon oxyfluorides you have xenon oxy dioxydifluoride, xenon oxy difluoride, xenon oxy tetrafluoride, like this. So all these are called as xenon compounds. So these xenon compound structure, shape, hybridization, and preparation properties, all of you have to study. Okay, the final topic in this chapter is clathrate compounds. What are clathrate compounds? These clathrate compounds consist of atoms or molecules of one substance acting as a guest and in the host molecule. What is guest and what is host? If you are what is that, if you are helping a person, that you are called a host. If you are helping a person to live, that is, you are called a host. And if you are the person who take the help, then you are called the ghost. Okay, guest, sorry. Okay, so this guest molecules like krypton, xenon, okay, argon. These three elements of the eighth group period, or eighth group elements, argon, krypton and xenon, they act as guest. Guest means they go and sit in the spaces that are available in some molecules. Some molecules, if they assume a structure of a crystal, in the between the atoms there are spaces, some small spaces will be present. So these eighth group elements, they can go and sit in the spaces provided there in between the atoms, and they form clathrate compounds. Okay, so the all the eighth group elements, they cannot be forming clathrate compounds. Only krypton, xenon and argon sometimes can form clathrate compounds, because helium and neon is of very very small size, so they cannot hold in the spaces. Okay, the clathrate compounds are also called as cage compounds. Okay, the weak interactive forces that are present between the guest and the host molecules are van der Waals forces. There is no real bonding between the guest and the host in clathrate or cage compounds. Okay, it is not at all necessary that all cavities in the host structure are filled. Okay, essential conditions for clathrate formation is there should be cavities of appropriate size in the host molecule. Size of the guest molecule should be such that it should fill the cavity of the host molecule. Okay, and uses of clathrate compounds you have to study. So krypton 85, that is the atomic weight of krypton, is a clathrate, provides a safe and useful source for beta radiation, useful for measuring of the thickness of the gags. Xenon clathrate provides compact source for gamma radiation. So these are used to provide radiations, gamma rays. Where the gamma rays are produced in the electromagnetic radiation, you will have different lights. Okay, whatever we are seeing is only the visible part of the electromagnetic radiation, but electromagnetic radiation is a composition of several types of radiation. So the high energetic radiations like gamma rays and beta rays are produced by these clathrate compounds. Okay, so this is about the uses and preparation of clathrate compounds. So students, make note of all this, and in the next class we will be studying about the halogen compounds. Okay, thank you.